It's math time with Heinz. It's math time with Heinz. Math time.
Hi everybody, welcome to lesson 9 here of our trig functions, which we talked about when I saw you last in person. So let's quickly review this because we're going to get into lesson 10 today. So we learned how to graph sine and cosine, and then we talked about, well, what if I put a number in front of it? And that number in front of it is called the amplitude. And it's a vertical stretch. It's a vertical stretch. So again, I'll show you here that the amplitude, if I change this a number, y equals a sine of x here, if I change that a number and make it larger, like, I don't know, 5, what that means, instead of going up 1, down 1, my peaks go up 5 and down 5. So what that amplitude does is it vertically stretches the function. It pulls those mountains and valleys and makes them taller. All right? And then we also talked about the midline. If I just add a number on at the end, this number here is representing the midline. Y equals k is the midline. What this is a vertical shift. It literally takes the graph and reestablishes what line my sine or cosine curve oscillates about. So it's a vertical shift. It establishes our new home base. So if I had, let me make this 1 again. If I had a k value of 3, what that does is it creates this horizontal line of y equals 3, and that's my home base. From there, then I can apply the amplitude to figure out how high and how low I go. So the midline and the amplitude are vertical stretches and vertical shifts that kind of are our first basic move, our first basic transformation of our trig graph. So let's look at number 3 here. Determine the amplitude and midline of this equation. So when we graph trig functions, my little acronym to help us out is MAPS. MAPS is what's going to keep us organized and keep us focused when we deal with trig graphs. M stands for the midline. The midline is that number at the end. Y equals 3 is the midline. I'm going to go to 3 and draw a little line in. The amplitude is 4. So from this midline, I go up 4, 1, 2, 3, 4, and down 4, 1, 2, 3, 4. The period, we haven't changed that yet because we haven't talked about that yet. So normally the period of sine and cosine are 2 pi. Unless I throw something else at you, which I will in 5 minutes, the period's 2 pi. And then the shape is cosine. What does cosine look like? Cosine is a big valley. A cosine graph is a big valley. So notice I'm giving you graph paper here. I just don't want you to sketch it freehand. So here's what we do. We plot 5 points. Cosine starts up high on the y-axis. I like to go over 2, so I'm going over 2 boxes into the middle, over 2 boxes into the bottom, over 2 boxes to the middle, over 2 boxes to the top. You can go over 1 box, but that would be really squeezing it in. So sometimes I go over 1 box, I kind of just judge, and you decide whether you go over 1 box or 2 box, that's up to you. The last thing we have to do, we did midline, amplitude, shape. The only thing I haven't labeled is the period. So right now, this looks like it ends at 8. But what I just did there is I rescaled my entire x-axis. Instead of this being the number 8, this is now the number 2 pi. So that makes this right here pi. So you always have to label your period because what that does is it then rescales your entire x-axis. What's the maximum value? Well, how high do I go? 7. Minimum, -1. So when I describe the range, well, how low to how high do I go? I go from -1 to 7. Range is describing the minimum to the maximum. When we describe the range, we're describing the minimum to the maximum. Okay, so this is how we graph a trig function on actual grid paper instead of just freehanding it. We haven't talked about even or odd yet, so let's just graph this. Let's just graph this and sketch it and see what we can do. All right, let's do a little maps here. Midline, amplitude, period, shape. Midline, that's your plus, y equals 2. Amplitude, careful, the amplitude is always positive. We have to remember, even though we see a -3 out front there, the amplitude is just 3. We haven't changed the period yet. But what shape is it? You got to be careful. It's a cosine graph, but there was that reflection that happened. So it's a negative cosine curve. Well, cosine is big valley. Cosine starts up high. So here, I'm going to start down low and swoop up. That's a negative cosine curve. That's the shape I'm going to make. All right, so my midline is 2. I'm going to just sketch that there. Amplitude is up 3, down 3. From my midline, from the middle, we go up 3 and down 3. What shape do I make? Low, middle, high, middle, low. And I swoop like that and hit those 5 points there. Last thing I need to do is always label the period on the x-axis. Where did I stop? I stopped at 2 pi. Okay, that's how we graph trig functions and sketch them. All right, 2 sine of x minus 1. 2 sine of x minus 1. So we've got to locate our midline, our amplitude, our period, and shape. We need to figure out, what do we know about this function? Well, the midline is the number at the end. That's our home base. -1 is really my new home base. It's normally the x-axis, but this time we're going to go with -1. I have an amplitude of 2, so I go up 2, down 2. From that middle, I have a period of 2 pi, and a shape. It's just a plain old sine graph. So sine is little hill, little valley. Sine starts in the middle. Sine always starts in the middle. Middle, little hill, little valley. Try to keep them equally spaced. And where does that end? Where does that one cycle end? Well, it ends at 2 pi. So on your x-axis, label where that one cycle ends. And let's work backwards now. Here's a graph. Tell me what the equation is. So y equals something. So we can still use maps, except we're going to work backwards. So what's the midline? Where's the middle of this graph? Well, you kind of just visualize it. Well, this goes up to 6 and -2. What's in the middle of 6 and -2? You can kind of just guesstimate where it is. I think this looks like the middle to me. 1, 2, 3, 4, 1, 2, it is. That is the middle. So the midline is y equals 2. The amplitude is from the middle. How far up do I need to go? From the middle, it's the length of that peak there. So the amplitude appears to be 4. The period, how long is one cycle? So I always start at the y-axis. Little valley, little hill. What graph goes little valley, little hill? Well, it starts in the middle on the y-axis, so it's got to be sine, but sine goes hill valley, so it's been reflected. It's a negative sine graph. Well, we haven't talked about changing the period yet. Notice this one cycle ends at 2 pi. So now I have all the information to write my equation. Y equals, it's a sine function. The midline is +2. The amplitude is 4. The period we don't need to worry about yet, but I need to throw a negative in front of it to make it go valley hill. All right, so we need to be comfortable working both ways. Here's the equation, make the graph. Here's the graph, make the equation. So that's kind of a quick review of amplitude and midline. Let's talk a little bit about period. Let's talk a little bit about, I gotta erase it here. Let's talk a little bit about period. We'll do a couple problems and then we're gonna call it a day. So we're in lesson 10 now, period and frequency. So let's try this opening exercise here. A pebble is lodged into the thread of a car whose diameter is 6. So I've got a circle here, right? And its diameter is 26 inches. Assuming the pebble begins on the ground, sketch a graph of the height if it takes 20 seconds to do a full spin. So the pebble starts on the ground here. I'm spinning around a circle. So where's the middle? The middle's 13. The highest I go is 26. So I start down low, right? Then I spin to the middle, spin to the top, middle, bottom. So this is the pebble's height. It's a trig function because I'm spinning around a circle. But notice, it didn't take 2 pi, it took 20 seconds. So in this case, the period is actually 20 seconds. And we need to talk about how does that affect the equation? Well, if that's 20 seconds, when do I reach the top? 10 seconds. Well, where do I reach that middle point? 5 seconds. 5, 10, 15 would go there. Okay? So we're eventually going to be dealing with word problems where we've got to deal with the midline, the amplitude, the shape, and the period. Well, the period is 20 seconds because that's one full rotation. 20 seconds is one rotation. That's the period. Okay? So the way that we affect the period, and it's not telling us what the period is, the way that we affect the period is we put a number in front of x. Normally that number is 1. Normally that number is 1. But watch what happens. Let's say I make that number 2. Notice my trig function got compressed. It got compressed. It got smaller. It got through the cycle faster. Notice it went from 2 pi down to pi. Well, what if I make it 4? Well, it happened even faster. The bigger that number gets, the quicker my trig function completes the cycle. One cycle. So the quicker I am here, the bigger that number is, the faster my trig function completes the cycle. What this number is telling us is what's called the frequency. When that number is 2, how many sine curves do I get in 2 pi? 2. When that number is 4 or 3, and that number is 3, how many sine curves do I make? I make 3 in that distance of 2 pi. So it still relates back to this idea of 2 pi. When I make it 4, I get through 4 cycles. So that number, this number here, tells us how many cycles do we see in 2 pi, and it's called the frequency. This number here is telling us the frequency. How many do I see in 2 pi? You don't see the period in the graph. You don't see the period in the graph. You see the you see the period in the graph. You don't see the period in the equation. You see the frequency. So let's work with this. What's the relationship? Well, that tells me how many I see in 2 pi. So 2 pi, the period, right? How long is one cycle? Is 2 pi divided by b. The period is 2 pi divided by that number. So what I like to do is bring that b up. BP equals 2 pi. I just find this easier to work with. BP, that's kind of our big equation, and this is the part that stumps everybody all the time. Whenever we deal with trig equations, we have to always basically use this equation. BP, the number in front of x, times p equals 2 pi. Okay, so determine the period and frequency. Well, frequency is b, period, I use the letter p for. So the frequency is 4. That's easy. I look at this, what's in front of my variable? 4. How do I find the period? How do I find the length? The period is the length of one cycle. Well, how do I do that? I do BP equals 2 pi. Well, what's b? b is the number 4. 4p equals 2 pi. And then I can solve for the period. 2 divided by 4 is pi over 2. So the period, the length of one cycle there is pi over 2. Frequency is easy. B is pi over 3. So how do I find the period? BP equals 2 pi. Well, I don't like that 3 in the bottom, so I'm going to multiply by 3. Pi p equals 6 pi, and we could say goodbye to those pi's, so the period here is 6. It takes me 6 units to get through one full cycle. And again, what number's in front of x? That's your b value, 2/3. So how do you find the period? That number times the period always equals 2 pi. And do times 3. 2p equals 6 pi, and then I divide by 2 and I get p equals 3 pi. So that's the period there. Okay? So let's graph these two functions here. Let's graph these and then we'll call it a day. 4 cosine of 2x plus 1. So let's think of our maps. Let's think of maps here. Not a lot of space. Midline, boom, y equals 1. Amplitude, 4. Period, we got to do a little bit of work for. The period is not 2. This helps me find the period. BP equals 2 pi. You have to remember that number in the equation is not the period. The number in the equation is kind of useless to us. The number in the equation is kind of useless to us. And what shape is it? It's a cosine graph. What does cosine look like? Big valley. Midline of 1. Amplitude of 4. 1, 2, 3, 4. So that brings me up to 5. From the midline, 1, 2, 3, 4, that brings me down to -3. All right, cosine starts up high. There's no negative in front of it, so high. Again, I'm going over 2. You could go over 1, but I like going over 2. Middle low, over 2, over 2. There's my cosine curve. And everyone always forgets to label the period. How long did that take? That took pi units. So even though we think that's box number 8, that's not 8, that's pi. That's how we graph on graph paper. All right, let's tackle this next guy. What do we got? We got -3 sine of pi over 2x minus 3. All right, let's do a little maths action here. Midline, amplitude, period, shape. So my midline is y equals -3. My amplitude, careful, amplitude is always positive. And you got to watch out for that negative. The amplitude is 3. The period comes from what's in front of x. BP equals 2 pi. Times 2. Pi p equals 4 pi. So the period here is the number 4. It takes 4 units to get through one cycle. Shape, well, it's a sine curve, but there is a negative in front of it. So, as my phone rings here, can I hold on for 1 second? Okay, perfect. Sorry, guys. So my shape here is negative sine. Little valley, little hill. So my midline's -3. From there, my amplitude is 3, so up 3, down 3. And now I draw the graph. Little valley. Watch, I'm going to go over 1 this time just to show you you can do that. If you wanted to go over 2, that's fine. Little valley, little hill. And then the final thing I have to do is label the period of 4. So little valley, little hill, I have a period of 4. And I'll see you guys in the next video.